Hello students, welcome to Unit 9 Notes, Section 10.6. You can pause the warm-up at this point if you'd like to write it down. It's only doubling or halving the radius or diameter. Just remember 2 radii equal 1 diameter, or 1 radius is equal to half the diameter. So today we're going to focus in on circles and arcs again, but we are going to stay away from really we're not going to focus too much on central angles or arc measure, but more we're going to focus on arc length today, okay, and congruent arcs. So instead of walking around your pool, let's say you're walking around the edge of a circular pool, that is a length. We talked about how it can be broken up into sections, which could represent portions of it, which are arc measure. So let's start with circumference and arc length. So remember, circumference is either pi times diameter or 2 pi radius, because there are 2 radii and 1 diameter. So in this case, if you take 1 diameter and you wrap it around, you can wrap it around 3.14159 times, because that's the length of pi. That's the quantity and scale factor of pi. So what we have, what we need to focus more on now is arc length. So what is arc length? Well, if we have an arc, let's say that's 60 degrees, we want to know how long it is, not necessarily just its measure that it's 60 degrees, but how long is that arc actually? Now, if we know what the circumference is, and then we multiply it by a portion of it, then we can find that particular length. Now, before I was doing this on my iPad and it ended up crashing. So I'm not going to rewrite the work, but I'm just going to go over what I wrote last time. So the length of an arc is equal to the measure of the arc over 360 times 2 pi r. So what is that really saying? Well, arc length is equal to the amount of degrees, always over 360, because there's 360 degrees in a circle, times circumference. So in this example here, I just threw some numbers down. 60 degrees, not the length of it, but the measure of it is 60. I totally made that up. I also made up that the radius was 4. But what would that look like? How long is it from A to B? Well, it is 0 over 360 times 2 pi r. So it's 60 over 360 times 2 pi, radius is 4 centimeters. And let me add a degree measure here. Okay. Now, now we could either multiply across, we could do 4 times 2 times pi times 60, or we could simplify this first. So it's really up to you how you want to do it. You can multiply across and then simplify. Sometimes it might be easier to simplify than to multiply across. So I simplified 60 over 360 to 1 over 6, and then I multiplied across. So 1 times 2 times 4 is 8 pi over 6, which simplifies to 4 pi over 3. So the length of that arc is 4 pi over 3, which is a little bit more than 4 centimeters, right? So, if I came up with an approximate value, it would be 4.18 centimeters. Okay. Let's see. The next question was, is it possible for 2 arcs of different circles to have the same measure, but different lengths? So I made 2 circles with the same exact measure. Notice that they both have a measure of 60. Again, just making that up. But you can tell that this is much longer than this one. So same measure, but our arc lengths are different if the circles are different sizes. Only when they're congruent circles, or when they're the same circle, will they have the same length and the same measure. Same length for the same measure. Okay. So then I moved on to number 4 here, which again, I'll just talk about what I wrote down. So the question here is, a car has a turning radius of 16.1 feet. The distance between the 2 front tires is 4.7. In completing the outer turning circle, how much farther does a tire travel than on the outside than on the inside? So we were given that its turning radius, so as far as it can go here, the outside, has a total length of 16.1. I'm sorry, the radius for this particular circle, my apologies, is 16.1. We were given that the difference between the tires, how far apart they are, is 4.7. So what we're going to do is 16.1 and take away 4.7, and we get 11.4. So the inner tire is 11.4 away, so I just drew it right here. We really don't need to use 4.7 anymore. It was just simply to find out the radius of the inner circle versus the radius of the outer circle. So I set up my equation, two equations, circumference of outer and circumference of inner. They both are 2 pi r. They both are 2 pi times, in this case, 16.1 for the outer, r being 11.4 for the inner. So we have 32.2 pi and we have 22.8 pi. If you need to pause it and write down all of your notes, you can. Okay. But then here we have 32.2. I want to find how much further the outer one travels than the inner one. So I'm going to do 32.2 pi, take away 22.8 pi, and because it's the amount of pi's that we have, pi is going to stay in it. So 32.2 minus 22.8 is 9.4. So I have 9.4 pi. And if I want to approximate it, I get 29.5 feet by doing 9.4 times pi. All right. Hopefully my iPad keeps going here so I can do the next example. A diameter of a bicycle wheel is 22 inches. To the nearest whole number, how many revolutions does a wheel make when the bicycle travels 100 feet? So we have that it has a diameter of 22, so that's going to be important, but we also want it to travel 100 feet. So the first thing I'm going to do, because I don't want to get tricked up with my units, is I'm going to multiply this by 12, because 100 feet times 12 is going to be 1,200 inches. It's always easier to multiply than sometimes it is to divide. So it has a diameter of 22 inches. So what is its circumference? So circumference equals pi d. So circumference equals pi times 22 inches. So circumference is equal to 22 pi inches. The question is, how many revolutions does it make? Well, one circumference is equal to one revolution. Let me move this over. I'll just call it one rev. So the amount of revs is equal to the circumferences. So the question is, how many circumferences are in 1,200 inches? So I'm going to keep that as simple as possible, but I'm going to do 1,200 divided by 22 pi. And you need to be careful. In your calculator, you're going to want to enter it this way, 22 pi. You want it to divide by both 22 and by pi. If not, you have to do them in two separate transactions. So you can do 1,200 divided by 22 divided by pi, or you can do 1,200 divided by parenthesis 22 pi close parenthesis. If you do anything else, like 1,200 divided by 22 pi, what it's going to do is, instead of giving you the answer 17.36 approximately, it's going to multiply after it divides by 22, which is not what you want it to do, and give you the answer of 171.36 or so. So again, when you divide this, you're going to say that this is equal to approximately 17.36. So it says the nearest whole number. So we're going to say approximately 22 revolutions. I'm sorry, I don't know where I came up with 22. I'm not paying attention. 17 revolutions. 22 was the radius, not the revolutions. Okay. So going back to this problem where we had a radius of 4 and we had an arc length of a little bit more than 4, think about how many degrees would work out where not only is a radius 4, but an arc length of 4 is 4. So imagine that this length was the same as this length. Okay, whoops. Well, it turned it into a straight line. But imagine what degree measure you would need to have. So when starting to think about that, we can do this thing called a radian measure. 1 radian is actually equal to about 57 degrees, a little bit more. Okay, so what we're going to do is we're going to practice converting degrees to radians. Okay, now what is a 1 radian? 1 radian is equal to 1 radian is equal to this. It's equal to the circumference divided by 360 degrees. So what it really is equal to is 2 pi r over 360 degrees. So in this case, ignoring any radius, it's actually equal to, we're going to get rid of circumference, and we're going to simply say it's actually equal to just 2 pi. Why? Well, imagine for every radius there are 2 pi lengths around, or there's 1 diameter. Circumference is equal to 2 pi. So let's just keep it as simple as this. Let's simplify it a little bit more. Well, 1 radian measure is 360 divided by 2 pi. Let me rephrase this. Let's go back to the beginning. If circumference is equal to 2 pi r, and the circumference is also equal to 360 degrees in theory, right? It's not in terms of length and in terms of a degree measure. Then let's set these equal to each other. 2 pi r equals 360 degrees. So what I'm trying to do is something that we never normally do, comparing a length to a measure. Okay, we don't normally compare lengths to measures because they're different, but just keep going along with my theory here. Let me solve for radius. So radius is equal to 360 over 2 pi. Instead of calling it a radius, let's call it a radian. And now we have 1 radian is equal to 360 divided by parenthesis 2 pi, which I get to be 57 point 2957, so let's say 0.3 degrees. It's approximately 57.3 degrees. And that's what 1 radian measure is. What it's saying is that if I were to take a radius and I create a central angle that is 57.3 degrees. So this was at 57.3 degrees. The radius would actually be equal to the length of the arc, and that's what we call a radian measure. Yeah, and there are 2 pi radian measures within this circle. So if you do 2 pi times 57.3, then you get back up to your 360 degrees. Okay, that's the theory behind it, but let's just do something simple and convert them. So here's what you're going to want to do. To convert a degree measure to a radian measure, there's one of two things. You're going to either, let me simplify this right here to be, whoops, let me zoom out. Let me put one more step in between that logic. Let me simplify it to be 180 over pi. So we're going to multiply everything here by either 180 degrees over pi or pi over 180 degrees. So in this first one, I don't want to multiply degrees by degrees. Nothing will go away. So I'm going to want to do the flip of it, the inverse. So I'm going to do times pi radians over 180 degrees. And so watch as this goes away. Degrees and degrees goes away. So we have 210 pi radians over 180. And that's going to simplify to be, let's see, 21 over 18. I can simplify it more though. 21 divided by 7. 21 divided by 3 and 18 divided by 3. And so 7, 6. So this ends up simplifying to be 7 pi over 6 radians. And we're done. Next one, 330. So let's do the same thing. Let's multiply it by pi radians over 180. So we're going to literally do that for all of these. So let me save some time for you, so this video is not too long. And I'm going to get rid of these. The purpose of getting degrees down to radians is there. So now we have 330 pi over 180. You can put radians afterwards. You don't need to put in a numerator. It is in the numerator now. So the question is, how does 330 over 180 simplify? So I'm going to do 330 divided by 30 and 18 divided by 30. Well, I divided both by 3, but they can also be divided by 10. So I get 11 pi over 6 radian. Awesome. Okay, next one, we get 15 pi over 180 radian, which is equal to, I think, both divisible by 3. So 5 over, let's see, 5 over 60. Oh, they're both divisible by 15, actually. Yep, 180 divided by 15 is 12. This is actually going to be 1 pi, or just pi over 12 radian. And we are done. Notice I'm not being lazy. I'm labeling these all as a radian because they're radian measures. This one is going to be 35 pi over 180, which will be 35 divided by 5. Yep, and that's all I got. So I got 7 over 36. So 7 pi over 36 radian. And I hope by now you're bored and you can do these all on your own. 45 pi over 180 whoops, is equal to, both are divisible by 45, so it's actually going to be 1/4 or 1 pi. Yeah, so I'm just going to say pi over 4 radians. And this one is 30 pi over 180. So it's pi over 6 radians. Now the popular ones that you'll be using a lot are pi over 4, pi over 6, pi over 3. So 45-degree angle is equal to pi over 4 radians. It's the same measure. 30 degrees is equal to pi over 6 radians. Yeah, so those are some of the popular ones that you'll see. Pi over 12 happens a lot of the time. Okay. Now, what we're going to do is we're going to go in reverse order now. So we are actually going to convert each radian measure to a degree measure. So now we're going to do radians to degrees. So what we're going to want to do is put degrees in the numerator. So I'm going to do 180 degrees in a numerator and pi radians in a denominator. Because really this should be labeled, in reality, this should be labeled as a radian. The software doesn't do it. So I'm just going to leave radian off here. I'll do it once, okay? But radian go away. Watch that. Look at that. Pi and pi go away. So now what we simply have is 11 times 180. So we have 1,980 degrees over 6. And we'll divide that by 6 and we get 330 degrees. And there you go. These tend to be a little bit easier because you don't need to worry about simplifying them. You just do division and then you get a degree measure. Now take a look. 11 pi over 6. See how we had that one up here? It was 330. So it's the same thing, okay? So we're just going the reverse direction. So I'm not going to label this radian, but what I will do is they are radians. You know what? Maybe I should just label them radian. I'll label them radian. Notice I'm abbreviating them. It's RADIAN. And I will multiply. Oh, you know what? I can do, actually, this will be much easier. So to save time, here we go. Boom. Boom. And we are just going to do that 6 times. Oops. Okay. So 3 times 180. Let me do those. Okay. 3 times 180 is 540 divided by 4. So it's going to be 540 degrees over 4, which is equal to 135 degrees. The next one, it was 1 pi, so it's really just number 1. So it's actually 180 degrees. 1 times 180, which is 180, divided by 6, which is 30 degrees. The next one, 29. Ooh, 29 times 180 is 5,220 all over 18. So 5,220 degrees all over 18 is 290. Sorry about that. Equals 290 degrees. Okay, should be a pro by now. Hopefully you can do the rest. on your own, but I'll finish these off. 180 divided by 4, which is 45 degrees. Don't forget that's not a 0, it's a 1. Okay, and then we have 360 degrees over 3, which is 120 degrees. All right. So really, you have to know how to convert them. You don't really need to know the logic of why it's there, but circumference again equals 2 pi radii, and circumference equals 360 degrees. And so if I want to solve for the length of 1 radii as a measure, it's called a 1 radian measure, not a radii or radius, but 1 radian. And so you just set them equal and you solve. So if you ever wonder what they are, I mean, keep it simple. 180 over 180 degrees over pi radians. Okay, that radian can move back and forth through division. So 1 radian is equal to 180 degrees over pi. So 1, the number 1 mathematically is equal to 180 degrees over pi radians if you divide both sides by a radian, which is what we're doing here, which is why we're able to solve by multiplying by pi over 180 or by 180 over pi. Okay, this next one, find the arc length of a circle with a radius of 6 centimeters and a central angle of 60 using each of the given arc length formulas. So if something is in a degree measure, this is our arc length formula, which we had above. If something is in radians, you can just simply multiply it by your radius, because your radian times your radius will actually give you your arc length. Now, how do they get that? Well, look at what's left over. Look at 2 pi divided by 360. 2 pi divided by 360 is equal to pi over 180. Oh, that's what we're just using above. So look at what's left over. That's 1 radian measure. So that's why the theta and the r follow. Okay, so we can do either one of these. We can use either formula, whatever one you feel more comfortable with. I'll show you both of them. So let's say we were doing 30 degrees. We know 30 degrees is pi over 6 radians, right? So 30 degrees. So we could do 30. You know what? Let's keep it consistent with what we're doing here. So find the arc length of a circle with a radius of 6 centimeters. So we have a radius of 6 centimeters and a central angle of 60. So 60 degrees is our central angle. Okay, so let me do 2 columns. What I'm going to do here is I'm going to convert it to radians. So I'm going to get 60 pi radians over 180, which is actually pi over 3 radians. Okay, so my measure for my first one is 60 degrees. My measure for my second one is pi over 3 radians. So now that I've done that workout, let me just make a chart here. Probably be easier. Okay, so let's find the arc length now. So this one is going to be arc length equals theta over 360 times 2 pi r. So arc length equals theta, so 60 over 360 times 2 pi times 6 centimeters. So arc length equals 1/6 times 2 pi 6 centimeters. Oh, running out of room. I want you to see the multiplication symbol. I want to make sure that's clear. Okay, so now arc length equals 6 times 2 is 12, so 12 pi centimeters over 6. So arc length equals 2 pi centimeters. Awesome. That was using our standard arc length formula, pi over 360 times circumference. So pi over 360, I'm sorry, theta over 360 times circumference. So theta over 360 being, we use 60. So now this arc length formula is different. Arc length here is just theta times r. We got this to be our theta. So it's going to be arc length is pi over 3 times 6. So arc length is 6 pi over 3. So arc length is 2 pi centimeters. Whoops, I forgot my centimeters earlier. We're done. So using the radian arc length formula, it takes a little bit more time to convert your angle over, but there's less simplifying involved at the end. Using your original one, probably less chance of making a mistake, I guess, if you're using degree measures, but either way, you get the same answer as a result. Okay, so find the arc length of a circle with a radius of 8 centimeters and a central angle of 2 pi over 3 using each of the given arc length formulas. Well, the first one is going to be much easier because the arc length one that's measured in radians is going to be much easier because it's going to be arc length is equal to theta times r. So arc length is equal to 2 pi over 3 times 8 centimeters. So arc length is equal to 16 pi centimeters over 3. And we are done with that formula. Okay. Now the other one, it's going to be a little bit more complicated. We are going to have to first convert 2 pi over 3. So theta equals 2 pi over 3. We're going to have to convert it to, we're going to have to do 180 over pi. So we are going to knock these out, and we will get 360 divided by 3, which is 120 degrees. So I just converted to degrees now. So now I get to use the arc length formula here. So arc length, when I'm doing it this way, arc length is equal to theta over 360 times 2 pi r. So arc length is equal to 120 over 360 times 2 pi, and r is 8 centimeters. So that can actually simplify to arc length equals, I'm going to say 1 over 3 times 2 pi, 8 centimeters. So arc length equals 8 times 2 is 16. So 16 pi over 3 centimeters. And we can't simplify it any further, so we're done. Notice in both cases, 16 pi centimeters over 3 is the beginning and end of that. Good? All right, so finding arc length, you can use either method you want, but because these appear to be in degrees, I'm just going to stick with degrees. So here we have a diameter of 16. I'm going to change that to a radius of 8 inches and a radius of 8 inches. So I have arc length is, oh, this is 90 degrees as well. Okay, so I have a radius of 8 inches. I have a measure of 90. So arc length is theta over 360 times 2 pi r. So arc length equals 90 over 360. times 2 pi 8 inches. Might as well simplify first. So 1/4 times 2 pi 8 inches. So I am running out of room. I would really like to fit this all up here, so you don't need to simplify in the next line. So arc length equals 8 times, let me put it over here. Arc length equals 8 times 2 is 16, so 16 pi over 16 pi over 4 inches. That simplifies. 16 over 4 is 4, so it's 4 pi inches. All right. Let me just pi over 2 times. Yep. Even if we did it the other way, it still would have worked out that. Perfect. Okay. I'm literally going to do the same thing for this one, so I'm copying and pasting everything. Copy to save time. However, I'm going to change the numbers around. So the degree measure and the radius will change. So I need to clean these up. Okay. So it looks like my radius here is 15 centimeters instead. And it looks like my arc length, my measure is 240 degrees, which is actually, this ends up being 2/3. So 240 ends up being, oh, let me just throw a measure on there. Okay, so we have 120 goes into 240 twice, and then 360 3 times. So it simplifies to be 2/3, so 15 times 2 is 30, times 2 is 60, so 60 pi over 3 centimeters. So my final answer, 2 times 2 is 4, 60 over 3, yep, so that ends up being 20 pi centimeters for the length. We're done. Find the length of a semicircle with radius 1.3 meters. Leave your answer in terms of pi. So a semicircle is how many degrees? Yep, it is 180 degrees. So we're going to say arc length equals theta over 360 times 2 pi r. So arc length equals 180 over 360 times 2 pi radius of 1.3 meters. Now you could have said, Mr. A, a semicircle is half a circle, so I could have just done 1/2 of the circumference. You can. That's where arc length is going to come in. So arc length is going to be 1 over 2. That's your 1/2 times your circumference, which is 2 pi r, which is 1.3. 2 times 1.3 meters. So we are going to do 2 times 1.3 is 2.6. So arc length equals 2.6 pi over 2 meters, which ends up being 1.3 meters. 1.3 pi meters. So you could have said, Mr. A, if circumference is 2 pi r, then isn't the circumference of a semicircle, instead of being 2 pi r, isn't it just 1 pi r or pi r? And the answer is yes, it is just pi r when it's a semicircle, which is 1.3 meters times pi. but arc length formula helps us get there. Let me write it out. Whoops. So that's neat. Okay. Next problem. 5 streets come together at, oh, by the way, these are word problems. I took them out of your homework. So really, your homework should be a little bit easier. So we got to just a little bit more. 5 streets come together at a traffic circle. The diameter of the circle is 200 feet. If traffic travels counterclockwise, what is the approximate distance from East Street to Neponset Street? So looks like we're going to label the diameter of the circle is 200. From East Street to, okay, I just want to make sure. So if the diameter is 200, it looks like the radius is 100. It looks like it's going, looks like any radius is 100, and it looks like they're repeating this over and over and over again. Okay, so the question is, I'm just going to do this one for you. So here, this is 90 degrees. This is another 50. And the reason why that's 50 is because it's an intersection. They're all 90 degrees, but it looks like that street falls 40 degrees here. So if this was a right angle and you take away 40 degrees, you get the other 50 degrees that you need. Let me change the color so it's easier for you to see. Okay. Because this appears that it's a right angle. So what we need to do is we need to find the distance from East Street over. So it looks like it wants us to find from there to there. So it's going to be a total of 140 degrees. So the arc length is going to be equal to arc length equals theta. Let me clean that up. What color didn't we use? Purple. Arc length equals theta over 360 times 2 pi r. Arc length equals 140 degrees, we said. Over 360 times 2 pi times 100 feet. Here is what's really nice about this. We don't need an exact value, we can approximate. So I'm just going to multiply everything across. 140 times 2 times pi times 100 is equal to about 87964.5943 over 360, which approximately equals 244. So you know what? I'm going to erase, no, I'll leave that, which approximately equals 244.3435 feet. Let me see if I can clean this up. And with that, we have our answer, 244 feet. All right. A 60-degree arc of circle A has the same length as a 45-degree arc of circle B. Find the ratio of the radius of circle A to the radius of circle B. So a 60-degree arc of circle A has the same length as 45-degree arc of circle B. So here we don't even need to draw the circle. So arc length equals theta over 360 times 2 pi r, right? So we have two of these, okay? So we have this one, and we have this one. And what we do know is one of them has a 60-degree, and the arc lengths are the same. So imagine that the arc lengths are the same. So in this case, AL is equal to AL. One has a 40, one has a 60-degree, times 2 pi r. So arc length for this one is 1 over 6 times 2 pi r. So arc length here what I'm doing is I don't know what the radius is, so I'm leaving it a variable. But I know that AL for this one is equal to AL for that one because they have the same arc length. So arc length is equal to 1/6 of 2. So it's going to be 2 pi r over 6, which is equal to 1 pi r over 3. So that's one of the arc lengths. I don't know the radius yet. This next one, I'm going to do the same thing, but I'm going to use 45 degrees. So arc length is equal to 45 over 360 times 2 pi r. Arc length equals 45 over 360. They're both divisible by 45. So 360 divided by 45, yep, is 8. Whoops. So we have 1 over 8 times 2 pi r. So we have arc length for this one is 2 pi r over 8, which is equal to pi r over 4. All right. This seems weird that I'm not even drawing them out, but I don't need to because this, a 60-degree arc of circle A, so this is circle A in orange. I'll highlight it. Circle A is orange, and then circle B is green. Those lengths are equal to each other. So now I'm going to set them equal. I'm going to say AL equals AL. So I have pi r over 3 equals pi r over 4. Okay. Find the ratio of the radius of A to the ratio of B. So A was the left side. So what's the best way to do this? Well, let's divide both sides by, let's do this. Let's do times 3 over pi times 3 over pi. Bear with me. We're going to get 3 pi r over 3 pi equals 3 pi r over 4 pi. And we're going to wipe these out. And we're going to wipe those out. So it looks like one radius is equal to 3/4 of the other radius. So here's a ratio. One radius is equivalent to 3/4 of the radius of. So find the ratio of the radius of A to the radius of B. So we can say one radius of A is equal to 3/4 of B, or we could say one radius of A is 3/4 of B. Wait a minute. A 60-degree arc of A has the same length as a 40. Yep, is 3/4 of B. Or if you multiply both sides by 4/3, 1 radius of B is 4/3 of A. It's just a comparison. So if circle A needed a 60-degree angle for it to be equivalent to the same length as 45, as a 45-degree arc of B, that means A has a smaller radius because it needs to be magnified by more. It needs to be magnified by 60 over 360, not 45 over 360. So in this case, it is 3/4 of the length of the other circle. But the other circle, if you were to instead and multiply both sides by 4/3, you would get 4/3 R equals R, right? Because this would go away. 4/3 would be 12 over 12. So let me just put that in one last different color here. I don't know if I have any other ones. I'll put or. And that's how they compare. All right, that one's a tough one. You probably won't see problems like that, but I just want to walk you through it regardless. Okay, the radius of a circle is 12 centimeters. What is the length of a 60-degree arc? So the radius of a circle is 12 centimeters. What is the length of a 60-degree arc? So arc length is equal to theta over 360 times 2 pi r. So arc length equals 60 over 360 times 2 pi times 12 centimeters. And so arc length equals 1/6 of 2 pi 12 centimeters. So it looks like we have 24 pi centimeters over 6. 6, 12, 18, 24. That's 4 pi centimeters. And that's our final answer there for that one. 240-degree arc has a length. Oh, why does this keep? Let's lock it in place here. Okay. A 240-degree arc has a length of 16 feet. What is the radius of the circle? So this one is solving reverse order. So we're going to say arc length equals 240 degrees over 360 times, oh, it has a length of 16 feet, but okay, you know what? Let me just leave it as theta. Times 2 pi r. So we're solving for the radius in this case. Okay, so we need to know what theta is and we need to know what arc length is. And we know both of those. Arc length is 16 pi. So 16 pi equals 240 over 360 times 2 pi r. Let's just do the math here. So let's do 2 pi times 240. So we're going to do 16 pi equals 480 pi over 360 times r still in the numerator, okay? And now to clean up both sides, what I'm going to do is I'm going to take this and I'm going to multiply both sides by its reciprocal of this. So watch this. I'm going to multiply this side by 360 over 480 pi. I'm going to do 360 over 480 pi. And the reason for that is to get rid of that fraction all in one step. So 360, 360, pi, pi, 480, 480. Look at that, you have r by itself. So you have radius is equal to pi and pi goes away. It's going to be 360 times 16 all over 480. So I'm going to do that out, and I'm just going to get an exact value here. 360 times 16 is 5,760 divided by 480. So my radius is 12 feet. And that's our answer. All right, last question. Amy is constructing a curved path through a rectangular yard. She will edge the two sides of the curved path with plastic edging. She will edge the two sides of the curved path with plastic edging. Find the total length in meters of the plastic edging she will need. Shade worker, explain how you find your answer. So there's two sides of the path. What we have here is let me increase that a little bit. You have this, and you have this, and you have this, and you have this. So these are 90-degree, these are quarter circles, but there's two of them, and they're all the same thing. So I could actually do a semicircle. Imagine if I took all of this data right here and I put it this way. Do you guys see that semicircle? Whoops. If I were to say that 90 and that 90 is put together, then I have a semicircle like that. Okay, so I'm just going to do the work once and make it a little bit easier on myself. Okay, I'm going to say the first circle is the inner one with 4-meter radius. So my radiuses are, I have two radiuses. I have a radius that is 4 meters, and I also have a radius that is 6 meters because it's the outer one. I also have a semicircle that is 180 degrees. I think that's the information I'd like to use for both of them. So my arc length of my first one, my inner circle, arc length is theta over 360 times 2 pi r. First one, arc length equals 180. Remember, I'm doing 90. Really, this is just 90 right here, right? But I am going to do the other 90 that's right up here. So 90 and 90 at 4, and then 90, 90 at 6. So 180 over 360 times 2 pi 4 meters. Arc length equals half of 2 pi 4 meters. 2 times 4 is 8, so half of 8 is 4. So it's 4 pi meters. So that's one of them. The next one, arc length equals 180 over 360 times 2 pi 6 meters. So arc length equals half of, let's just combine that, 12 pi meters. So half of 12, it's 2 times 6 is 12, yep, so half of 12 is 6 pi meters. So now the last thing is arc length total. Because I did it twice, I get 4 and 6, so I get 4 plus 6 is 10 pi meters, which, find the total length in meters. So we don't normally leave it 10 pi. We would actually do the multiplication because we're talking like a real world example. So it is approximately equal to 31.42 meters. I would probably just say 31.4. All right. So that was a long lesson. I know they're going to get shorter, but you guys can start the notes for 10.6 and book me with any questions that you may have. Hopefully these are easier for you to do. Don't forget you have a corresponding, looks like it's only one page of homework to practice, converting between radian and degree measures and vice versa. And then don't forget all your iExcel. That's what's actually being graded. Okay, good luck.